Okay, we're live again with first period. Say hello, first period.
Hi.
All right, we're gonna look in this video. We're gonna just focus on questions 11 to 18. Again, this is my best guess. So some of you from the brain break are still on the phones. I just recommend turning them over so you can focus. All right, here we go. So what is the measure of angle 2? Well, let's talk about some things before we get the answer. How many degrees are in a triangle? How many degrees are in a straight line? Excellent. Okay, so technically speaking, this is the exterior angle theorem. The exterior angle theorem says that the exterior angle to a triangle is equal to the sum of the opposing two interior angles. Let's say you forgot that. The first thing that you can do is first just look at this triangle. This triangle right here, we have 42 and 30. So we could just take 180 degrees in a triangle, subtract the 42, which would give you 138, right? Yep. And then subtract the 30, which would leave you with 108. And now we know this is 108 degrees. And then you can look at, well, a straight line has 180 degrees. So when we have our 180 degrees and we subtract the 108, we get 72. So, yep, in 1 second.
Okay, Doctor, I have a question.
Yep.
Because I did that, but I didn't. I added 42 plus 30 and got 72. Then I subtracted, I did 180 minus 72, which I got 108. Then I did 180 minus 108, which is 72, and that's how I got my answer.
Yep, that works. And then the quickest way to do it, though, is look at, if you just add 30 plus 42, what do you get? 72. That's what the theorem says, is all you do is you just add those two up and that gives you the answer. Okay. All right. Denisha's going to talk us through the next one. What is the measure of a base angle of an isosceles triangle if the vertex measure is 38 and the congruent sides are 21? So first of all, what piece of information do we not need? Okay. I need a specific person to go back to the specific person's seat and work on math. Okay, so what am I going to put for the base angles?
Well, I did 180. I did 180 minus 38, and then I divided it by two.
Yeah, that is definitely one way you can do it. What she did is she knew 180 degrees is in a triangle. So she subtracted the vertex angle that gave her 142. And then she divided that by 2 because there were 2 angles left and she got 71. That is definitely one way to do it. The other way you can do it is you can say, well, this angle and this angle are each x. So the algebraic way to solve this problem is to do this. Okay, this gives you 2x plus 38 equals 180. Subtract 38 from both sides and divide both sides by 2. Yep, either one works. I agree, but that's like the official way to do it if you wanted to.
I'm sorry.
Next, it says, given the following diagram, I expect you're going to see at least one question like this because it's one of the fundamental geo concepts, is the idea of mid-segment. So it says, given the following diagram, this one's super easy, but it says AB is parallel to which line? Yeah, YZ.
Wow. Oh, no, I'm sorry.
Just a couple things to remember. Let me make this diagram bigger. Okay, these lines, these inside lines are called mid-segments. And because they're mid-segments, that means that this line here is equal, excuse me, recording, is equal to this piece here. And I showed you before that you can just kind of see the hidden parallelogram. And so sometimes if you just color in the hidden parallelogram, it'll help you out to see. All right, in 14, it says in the figure shown below, WXYZ is a parallelogram, so that's good information, with those diagonals. Well, let's think of things that we know about parallelograms. We know that the opposite sides are congruent. We know that the opposite angles are congruent. And we know that the diagonals bisect each other. So those are the things that we know. So I'm going to just say, well, WX has to be congruent to ZY. WZ has to be congruent to XY. ZD has to be congruent to XD. And then I'm just going to put a circle because I don't feel like drawing 4 lines. Those pieces have to be congruent. So now we have to see what matches. Well, if we do DYZ, DYZ is down here. Does that match DXY? Do those two triangles look the same? This one's got a red, yellow, and green. This one's got a yellow, green, and blue. So it can't be that one. So it's not A. Then it says WDX, which is this one, and YDZ. So we've got red, yellow, green, red, yellow, green. So yep, that's our correct answer. So it's choice B.
Well, are we supposed to pick 2? Oh.
We pick one answer choice that includes 2 triangles.
Oh, I picked 2. Isn't there 2, right?
Is there 2? What was the other one that you got?
Can it be C2? It can be WDZ and XY. Yeah.
Hold on. WDZ.
Yeah, because they have the little bisection triangle.
Here's W, then it goes to D. So this is a yellow line. And then YD. No, it can't. Because.
You said YD. It's XD.
Yeah. I was saying YD because it had to be YD. So if we do WD, I'm going to make that blue. And that means we know that the 2 blue lines match. So this says WDZ. So this is our first angle. So that means this would have to be our first angle. Because they have to match, right? Here's our 2. So for it to go 1 to 2, it's blue. And this would have to be our third angle. So WDZ matches YDX because the order of the letters matter. Okay? Good question. Yep. All right, 15. Does anyone still need that? Okay, 15. An accompanying diagram of the rhombus, QRST, diagonals. Well, it says rhombus, so right away we know that all the sides are the same. Diagonals QS and RT intersect at M. We also know that their intersections of a rhombus form right angles. Those are the 2 main features of a rhombus. Rhombus is all the, nope. Diagonals are congruent for rectangles. Rectangles and squares. So the main things for rhombus is all the sides are the same measure and the diagonals form 90-degree angles. So which statement must be true? Triangle QRM is an obtuse triangle. Well, that can't be because it's got a right angle. So it's not A. QS and RT are congruent. That's only if it was a rectangle or a square. So it can't be choice C or choice B. Triangle QRM is an isosceles right triangle. That would only be if it was a square. Yeah, it has to be. And then it says QRM, so starting at Q, going to R, and then going to M, is equal to starting at S, going to R, going to M. Yep, that's true. Yeah, I just wanted to show you, I wanted to reinforce rectangle and square. That's why I did each one. Jim asserted that some, but not all parallelograms are kites. Which of the following pairs of figures justifies his assertion? So what a kite is is, why is he saying? Oh, that some but not all. So, yeah. Wait, what are we talking about? Yes. Well, actually, it's reflexive because of. So it's reflexive, so you can do a hypotenuse leg because this side and this side are the same because it's a rhombus. This is a right angle here, and this is a right angle here because the diagonals of rhombus bisect or create right angles.
So it doesn't have to be.
Correct. Nope. And then the leg, this is reflexive here, which gives you hypotenuse leg. So the hypotenuses are the same, and then the leg is reflexive. And it's a right angle because of the rhombuses. Okay. The answer to this is B.
Wait, why is it B?
Yeah, I'm just looking. It says, Jim asserted that some but not all parallelograms are kites, which, oh, I see what he's saying. Okay. So a kite is a consecutive. Sides are congruent. So the reason, oh, I don't know why I made that congruent sign look so stupid. Congruent. Okay, so it can't be choice A because this isn't a parallelogram. So we can't, because that's not a parallelogram, we can't look at that one. It can't be choice C because choice C is not a parallelogram. So now we're stuck here. And then it says some but not all are kites. So this one is not a kite, and it's not a kite. I would be surprised if you get this question, but I'll explain it. These two sides are not the same measure. So because they're not the same measure, it's not a kite. This side and this side is not the same measure. So it's not a kite. But because Jim said some of them are kites, you have to look at which one of them is a kite. And the square is a kite because these are the same. And this is not a kite. So that's why it's choice B. Because he gave an example of one shape, one parallelogram that was a kite, and one parallelogram that was not a kite. A and C I didn't count because neither one of those are parallelograms. Okay, two more and then we'll brain break. Given AB and DF are parallel, what's the best measure of BE? Now, here's AB, here is DF. Don't get caught up thinking mid-segment because it didn't mention mid-segment. This is just a straight, easy proportional problem. If I could just say the word proportional. So all we do is we set up the proportion. You guys are doing good. We're almost taking another brain break. 12x. 18 times 5 gives you 90, I think.
Yeah.
Okay.
And then the log of 5 by 4. X equals to what? 7.5.
Thank you. Choice B. Okay, this is why we're stopping after this one because it's ridiculously long. Again, I would think number 18 might be an example of what you could see on the DA, but I'd be surprised if you see it on this SPG tomorrow. The DA is what you take on the 20th. I know. In the following figure, it does tell us that EDBC is a parallelogram, so I'm just going to right off the bat mark these notations. Why does CD divide AF and BF proportionally? Hold on. Why does CD divide AF? Here's AF. AF and BF proportionally. I just made it green and red. And why does DE divide AB and AF proportionally? All right, I'm guessing it's got to be something with similarity. That's my best guess. Okay, because is it? Because anytime you see the word proportional, remember proportional always means similar. Okay, so right away, let's just lay that out there. So I think it is A. Let me double check. It is A, but let's go backwards and see why it's not the other ones. Because opposite angles in a parallelogram are congruent. Well, that is a true statement, but that has nothing to do with proportionality. So it can't be choice D. Opposite sides of a parallelogram, that is also true, but that doesn't have anything to do with proportional. Because triangle ABC, well, here's triangle, it's not, there's even no such thing as triangle ABC. You'd have to draw it yourself. Yeah, it's got to be A. I don't know even what that one is. So only because of the word proportional. Anytime you see proportional, proportional means similar.